Okay, so today we're going to start the lesson on inequalities. We're going to be breaking it up into 3 days. Today is pretty much a review of Algebra 1. The only thing we're going to add in is interval notation, and that's how you're going to be writing your answers. Now, when you do the homework tonight, you're going to be solving them. You're going to be writing your answers in interval notation, and you're also going to be graphing them. Okay, so you're going to solve them, write your answer in interval notation, and then graph it. Next slide is just talking about when you solve them using addition or subtraction. They're also talking about when you multiply or divide, you would reverse the symbol. So I'm just going to get right into the notes and show you how to do these. So the first one, it's just a simple addition inequality. We would solve this as if it were an equal sign. However, instead of putting an equal sign in our answer, it's going to have one of the inequality symbols. So in this case, it's starting out as a greater than symbol. So I'm going to first start by subtracting the 5 from both the left and the right side. Cancels from the left. I'm left with negative 3x is greater than negative 12. Here's where the tricky part comes in. Whenever you multiply or divide by a negative number, your inequality symbol reverses. Now, this is when the negative sign is with the variable. So, negative 3 divided by negative 3, that would cancel. I'm left with x. I now reverse the greater than and make it now less than. And then I divide negative 12 by negative 3 and get positive 4. Now, when you graph this in Algebra 1, we would put our, circles on the graph. So I'm just going to put the 4 here. It would really be like 4, 3, 4, 5. Now, when we graphed it in Algebra 1, when the symbol was a less than or a greater than, the circle we put on the graph was open. When it's got the or equal to, we would put the closed circle. So this one was a less than symbol. So I would have put an open circle on the 4, meaning that this is my starting point, and then all numbers that are going to be less than 4, and I would point it in that direction. Now, when it's pointing towards the left, that is pointing to the negative numbers, so it's going forever to negative infinity. When it's going to the right, it's going to positive infinity. So when we go to write our answers, instead of using open and closed circles now, we're going to be using parentheses for the less than and the greater than. And we're going to be using brackets around the numbers for the greater than or equal to or the less than or equal to. So notice in my graph, when it's a less than, what you're going to do is you're going to put negative infinity up to where it stops. So you're reading like from left to right. So this graph is really covering everything this way. So I'm reading left to right. I'm starting at negative infinity. I hit 4. I stop. It was a less than, so I put parentheses. Now, around the infinity and the negative infinity, it's always parentheses. They never get a bracket. Okay? Yes?
Do we have to show the graph and the interval notation for the homework?
Yes. Okay? So the instructions in the homework say to graph and write your answers in interval notation. Now, when you go to check your answers, they're actually, again, not using the opened and closed circle. So on the graph, what they're going to show is instead of this graph, what they would show is the parentheses here and then pointing it this way. So instead of the open circle, they put a parenthesis on the graph.
But can we do the open circle or does it have to be?
Do it like this because this is how you're going to, so you don't get confused. Okay? But just be aware that, you might see on the SAT or the PSAT the open circle, or you might see a parenthesis, or you might see a bracket and a closed parenthesis. So just be aware that both things are taught in high school because the open and closed circles are taught in Algebra 1, but now in Algebra 2, we're using parentheses and brackets. Let's try another one. Again, this is just an explanation of the graphing and the interval notation. And again, these were all just screenshots from your textbook. Okay, so I need to now solve this inequality. I need to get my variables on one side and my numbers on the other. It doesn't matter which way I move them. Now, if you're afraid you're going to forget to flip the inequality when it's a negative, move the 3 over this way and make the x value positive. It doesn't matter which way you move them. I know a lot of people like moving letters left. You could have moved the 2 over. You could have subtracted it. Either way, we're going to get the same answer. So I'm going to add the 3. I'm left with 4 is less than or equal to 7 plus 5x. And now I'm going to move the 7. And I get negative 3 is less than or equal to 5x. I now need to divide by 5. Negative 3/5 less than or equal to x. Now, for those of you who like to see your letter on the left, you could move it around. Make sure Mr. Pac-Man here is still eating the x, so you would flip him around so he still is going after the x and not the negative 3/5. We now need to turn this answer into a graph and to interval notation. So if I were to graph it the old way, remember this would have been a closed circle on negative 3/5. And it was greater than, so it's going this way to the positive infinity. Now the new way for the graph, instead of a closed circle, what I'm going to put on negative 3/5 is a bracket and still point it in that direction. My interval notation is going to have negative 3/5 with the bracket, and it goes to positive infinity. So when it's greater than, it'll be the number and positive infinity. When it's less than, it'll be negative infinity and then the number. And the bracket symbolizes this symbol or this. So those symbols get brackets around them. These symbols get parentheses around them. And so do the infinities. So infinities and the less than without the underline or the or equal to get parentheses. This will help. So for the greater than or greater than or equal to, it's going to be the number and then infinity. Now this number could also have a bracket. Okay, for the less than answers, or less than or equal to, then that would be negative infinity with a parentheses, and then it would be the number, and it's either going to be a parenthesis or a bracket. Everybody with me on those? So that's the bottom line here. Now, when it's a compound, then it's going to have two numbers and not an infinity or a negative infinity. And we're going to get to those in a minute. Okay, those are the segments when you did those. Those are the ands. Let's try another one. Just this simple. Now we're going to get to the compound. So here you go. Example is a compound. Notice I have 3 parts. All the other ones I had a left side and a right side. Now I've got a left, a middle, and a right. Now, sometimes in Algebra 1, they probably told you pull them apart, solve them separately, and join them with the word and. I like to just solve this all together. So instead of just doing something to the left side and the right side, I now need to do the same thing to the left, right, and middle. So I'm going to, again, my goal is to get x all by itself. So I'm going to first subtract 5 from the left, from the middle, and from the right. So now my goal is to get x that's in the middle all by itself. So far I've gotten the 5 out of there. So I get negative 7 less than 3x less than 15. Again, my goal is to get x all by itself. So now I'm going to divide all three pieces by 3. I'm now left with -7/3 is less than x, which is less than 5. So now let me graph it the old way. Now again, in Algebra 1, they might have said, okay, we're going to graph this solution. So x greater than -7/3. That would have been an open circle, and that would have meant it goes this way. Then when you go to graph this part, you're graphing x less than 5. Again, open circle, and it would have been going this way. When it's compound, your answer is the overlap. So my answer for this is really, let me write it this way now, -7/3 and 5. So then now I would have put a parenthesis, and you join it in the middle. Because the overlap, it's got to be where it satisfies both. So really we're looking for the numbers in between -7/3 and 5, not including those numbers. My answer here in interval notation is just going to be the -7/3, 5. And again, because it's just a less than symbol, you surround them in parentheses. Sort of looks like an ordered pair. So when you see answers like this is going to tell you it's like a range of numbers. It's a segment. Another nope, this is a simple one. All right, so the first thing I need to do is distribute. Then I'll combine my like terms and then eventually solve for x. So I'm going to distribute this subtraction sign. So 6x minus 2x minus 3 greater than or equal to 4x minus 5. Before I begin moving my terms, I'm going to combine these like ones and get 4x minus 3. Now I can begin trying to group my terms. I'm going to actually move the 4x first. Now at this step, you're going to look at this. Notice my variables are all gone. Now I have to interpret this. Is this statement true or false? It's true. Now if it were false, my answer would be no solution. Yes?
Would you be able to do like add 3 on the...
So when you get a true statement, the answer is going to be all real numbers, but again, we're writing it in interval notation. So all real numbers would be represented from -infinity to +infinity, and it's in parentheses. So if you were to have graphed this, it would have been the whole number line. Yes?
Why is it in parentheses if it doesn't have the other line?
Because the infinities never get a bracket, because the infinities never stop. It just keeps going. So infinity and -infinity never get a bracket. It's always parentheses because it goes forever. Now, if this were a false statement, the answer would be no solution. So when your variables cancel, you've got to look to see, is my statement true or false? And then from there, it'll be either all real numbers or no solution. This next question is starting out as a division problem. So again, I need to get rid of that fraction. So in order to get rid of the -8, I'm going to multiply by -8. So you can either think of this as multiplying the whole thing to clear the fraction, or multiplying this side by -8 and this side by -8. Remember, when you do the other side, you're going to distribute it. Yes?
Do you flip the sign?
Yes. So whenever we multiply or divide by a negative number, this symbol is going to reverse. So this side cancels the -8. I'm left with 2x minus 5. My inequality symbol is going to reverse and turn into a greater than or equal to. And now I distribute the -8. I get -8 plus 8x. Now I can try to combine my like terms. So again, it doesn't matter which way I move it. I could move the 2x over to the 8x or the 8x over to the 2x. I'm going to get the same answer either way. So let's move the 2x. Try to keep our variable positive. That way I don't have to worry about reversing any inequality symbols. So -5 greater than or equal to -8 plus 6x. I now need to move the -8. 3 is equal to, or greater than or equal to, 6x. I'm dividing by 6 to isolate x. I'm going to reduce 3/6 to make it 1/2, greater than or equal to x. And again, I like to get my variable on the left. So again, if it helps you to draw Mr. Pac-Man around this guy, and you see that he's eating Mr. 1/2, you'll flip it around, and x is less than or equal to 1/2. So again, graphing it the old way, I'd put 1/2 here. It would have been a closed circle pointing this way. So again, remember this side is the -infinity, positive infinity, or just remember for the less than or the less than or equal to, you write the -infinity and then the number. Infinity and -infinity always gets parentheses. And then because it's got a less than or equal to, the 1/2 gets a bracket. I'm also going to graph it the new way. So instead of a closed circle on 1/2, I put a bracket. Question. Okay. Help clarify the order to put it in the interval notation. When the symbol is a greater than symbol, so if it's like this, then what we're going to do, so like if it's a variable and then a number, the way that you're going to write it is going to be the number, comma, infinity, and because it's just going to be a greater than, it's going to be a parentheses. Now, if it's a greater than or equal to, like this, then you would write a number, a bracket, because it's got the or equal to, the underline, and then the infinity. Now I'll show you the same thing for the less than. So for the less than, you would do, so just plain less than. So let's say it's x less than a number. Again, it's pointing to -infinity, comma the number. Infinity always gets parentheses or -infinity. And then the number, because it's plain less than, gets a parentheses. If it's less than or equal to. So again, like this. Then it's -infinity, still with the parentheses. And then the number gets the bracket. And then remember that your compound doesn't have infinity. Doesn't have infinity or -infinity. And it's either going to be two parentheses, like number, number, or number, number with brackets. It can even have a combination of a bracket and a number, depending on the symbol. So like this would have been like two less thans, or two less than or equal tos. You could also have one of each. Yes?
What are you talking about when you say compound?
I'm going to show you another example of that. That's where it had the three parts. And we just did one of those. But I'll do another one of those in a minute, and I'll clarify. Yes. Okay, let's try another example. All right, so for this one, I got a bunch of fractions here. Instead of trying to work with fractions, I'm going to clear the denominators. So I'm going to multiply everything by the common denominator, which is 6. So here, I'm going to multiply my entire thing by my common denominator, which is 6. So I'm going to distribute it here, here, here. This is all one term, so I'm only going to distribute it to the 2/3, and then finally to the 4/3. So when I distribute it to the negative 2/3, I'm left with, I could simplify diagonally, make that a 2, and then that turns into negative 4x. So negative 4x. Then when I go here to the next term, it's already got the 6 in the denominator, the 6 totally cancels, and I'm just left with negative 1x. Then I'm going to distribute it to the 2/3, and from there I'm left with 4x, or just 4. And then the parentheses, so plus 4, and then the x plus 1. I don't distribute the 6 into the parentheses. Still have the same symbol. And then lastly, it's going to get distributed to the 4/3, and then this becomes 8. Now I'm going to distribute 4 times x and 4 times 1. I'm now going to combine like terms. So negative 4, negative 1, and positive 4 leaves me with negative 1x plus 4 less than or equal to 8. I'm going to move the 4, subtract it, divide by negative 1. When I divide by a negative, my symbol reverses. It goes from being a less than or equal to being a greater than or equal to. And now if I graphed it the old way, this would have been in a closed circle pointing to the right. So let's go ahead and add in the interval notation. It's a greater than, so it goes the number, because again, remember we're going from towards infinity, and it has a bracket because it's greater than or equal to, and again, the infinity gets a parentheses. So graph the new way. Instead of the closed circle, you're going to put a bracket and point it to the right. Yes?
So, we're only supposed to do the new way, not the other way.
Correct. So your answer for the homework is this. I still want to see all the solving process, but that's the answer when you go to check them tonight or on the weekend. That's the answers you're going to see from that odd answer file. Next one is the compound that I had written in green on that other slide, where we don't have infinity in our answer. So here we go. So again, I've got a left, a middle, and a right. I need to do the same thing to all 3 parts of my problem. So I'm going to subtract 5 from the middle, from the left, and from the right. I end up with negative 9 is less than 3x is less than 3. I now need to divide each piece by the 3, because again, your goal is to isolate the x. So then I'm left with negative 3 is less than x is less than 1. When we go to graph these compound, put the negative 3, positive 1, and again, the new way, what you would do is put parentheses, parentheses, and join it in the middle. Because again, this is a range. The answers are any number that's in between negative 3 and positive 1, not including negative 3 or positive 1. Interval notation, it's just the 2 numbers on the ends. Put them in this thing least to greatest. Another compound, again, do everything to the left, right, and middle. So again, my goal is to get x by itself, so I'm subtracting 3 from all 3 parts of my problem. I get negative 9 less than or equal to 6x less than or equal to 18. I now need to still get x by itself, so now I divide by 6. All 3 parts. I'm going to simplify negative 9 over 6 to negative 3 over 2. I'm going to divide 18 by 6 and get 3. Now notice my symbols are less than or equal to's. So this time they'll be brackets. So again, in the interval notation, -3/2, comma 3, both of them surrounded with brackets. And again, if you were to graph it, -3/2 first, then the 3, bracket, bracket, connect it in the middle. Because again, if you recall from Algebra 1, if you thought about graphing just this one, this would have been right here on -3/2. It would have been closed circle going this way. Then this one, x is less than 3, closed circle going this way. In the compound answers, it's where you see both the red and the blue lines. I mean the green and the blue. So it's the overlap. So that's why your answer here is just a segment. So even when you did this back in Algebra 1, it would have been closed circle with a segment joining them in between. Let's do another one. Compound again. This time we're going to reverse. So we're going to still subtract 5. -1 greater than -6x greater than -6. Notice I'm dividing by -6 to isolate x. So this time I reverse all my symbols to opposite of what they were. Notice the negative divided by negative. Notice my answers became positive. So now I would graph. Again, my interval notation, parentheses around the two numbers. And again, the number line, 1/6, +1, parentheses, parentheses, connect in the middle. Old way would have been open circles. Last example is another compound, but we're getting rid of the division, so we're multiplying everything by 3. So I'm essentially multiplying my entire equation by 3. This becomes -15. This becomes x minus 3. And this becomes 3. Now I add 3. -12 less than or equal to x, which is less than or equal to 6. Again, in interval notation, -12, comma 6 with brackets because it's less than or equal to. And again, on the number line, it's going to show bracket, bracket, connected in the middle. So those are your inequalities, the first day of section 7. Your homework is page 156, 13 through 33 odd. So you're solving, you're writing it in an interval notation, and you're graphing the answers.